Hello, everybody. Bonjour, hi, Canada. It's Professor Rehse here again. So excited to join you on another one of our DoD K-12 STEM Saturdays. It is the beautiful month of April. We are in our ZIIGWAN Primavera spring edition of our DoD K-12 STEM Saturday. So we're going to be talking about a spring type topic today. Before I get to that, I just want to give a shout out to the Canadian students who have chosen to join us today. I believe this is the first week where we're getting some Windsor schools involved in our little talks here. So thrilled to have you all with us. And we hope that you will continue this for many weeks to come through the summer and maybe even next year. So with that said, let's go ahead and get started on this promised spring topic that I said I would have for you. So what I want to talk about today is Isaac Newton and his famous apple. We've all heard the stories, and today we are going to learn about what was really true with Isaac Newton. And then if you hear Newton and Newton's apple, why is it? Why is Isaac Newton associated with an apple? What's going on with that? So going to be a very interesting spring topic for us all. So let's dive into that. Before we can dive into that, of course, we have to start off with our land acknowledgement statement. So the University of Windsor does sit on the traditional territory of the Three Fires Confederacy, the First Nations, which includes the Ojibwe, the Ottawa, and the Potawatomi. We respect the long-standing relationships with First Nations people in this place, in the 100-mile Windsor-Essex Peninsula and the Straits Le Détroit of Detroit. So very pleased to have this opportunity to talk to you from this land that we are very lucky to share. So I want to talk about Isaac Newton, the man, the myth, the legend. So let's start with the man. Here's a nice little picture of Isaac Newton here. So you can see he's in this kind of, this is not a picture of the time. This is a modern retake of what Newton would look like, but it shows a bunch of things in the background that he's famous for, and his work on gravitation and planets. And he's got a prism here where he's dispersing white light into colors of the rainbow. He studied that a lot in this book I'm going to talk about. But then there's this apple tree behind his head, always the apples with Newton. So there's something going on in the legend of Isaac Newton. So who was Isaac Newton? Well, Sir Isaac Newton was a British physicist, and he lived from 1643 to 1727. So that's about 300 years ago. He was one of the first and certainly one of the most famous physicists that has ever been. And he's known for a lot of things, and that's kind of what we want to talk about today. So at the time when Newton was doing what he did, he would not have called himself a physicist. That word didn't exist yet, but he is really recognized as one of the founders of the field of physics. So one of his biggest contributions, well, what did he do? He did a lot, but I just want to talk about one of his biggest contributions here. In 1687, he wrote what I consider to be one of the most important books in the history of the world. Certainly, I think it's the most important scientific book in the world, but it definitely rates up there in one of the top 100 books ever written in the history of the world by mankind, and that was called the Principia Mathematica. And interestingly enough, he got a lot of encouragement and actually financial assistance for producing this text from Edmund Halley, of famous Edmund Halley of Halley's Comet fame. So for those of you who have heard about the comet, they were contemporaries of each other. And Halley, with his observations and the work on the astronomical objects, was certainly encouraging Newton to work out his ideas in the Principia. Sometimes we just shorten the title of that book to the Principia. In this book, he worked out for the first time what we call these universal laws of motion. The universal laws of motion are some laws of physics, and they were indisputable. And as far as we knew, 100% accurate for over 200 years, until Einstein came around and added a correction to that. Here's a famous picture of Einstein with his tongue sticking out, maybe letting Newton know that he's one-upped him there. But we still teach all of these Newton's laws of physics today. In fact, we give it a name and we call it Newtonian mechanics in honor of Isaac Newton, who worked out all of these laws of motion. So if you think about spaceships going up into orbit, and we recently put a new rover on Mars. How do we get there? That's all Newtonian mechanics, the motion of objects in our universe. In this book, the Principia, as he was working out the universal laws of motion, Newton introduced the use of a Latin word gravitas, which is the way he kind of summarized this effect that we would come to know later as gravity. So we're going to talk about gravity today, and most of us have heard the word gravity. We know what gravity is, but Newton was the person, what we're going to be talking about today, who worked this idea out. And so he initially called it gravitas. So this is a very, very important book. And in fact, in 2016, a first edition of that book actually sold at auction for $3.7 million, the highest price ever paid for a printed scientific book. So it's really, really an important book, and it's a very important historical document as well. So let's talk about gravitas, this idea he came up with, which we call gravity now. So I have a little animation here on the left of a girl jumping up and down on a trampoline. So I have some neighbors who just recently installed a trampoline in their backyard, and their daughters are always jumping up and down on the trampoline. And I just think this is a great analogy because it shows what people know about gravity. Everyone knows about gravity. I would say every human who has ever existed on the face of the earth knows gravity, because you know that if you jump up, you come back down. Everyone knows that. No human who has ever existed has jumped up in the air and not come back down. So everyone intuitively, from the time you are an infant and learn to stand, understands gravity, this thing that brings things back to earth. And if you try and throw something up in the air as high as and as hard as you can throw it, it's gonna come back down. It always does. That's gravity. We intuitively know that. Gravity is also, in this animation I'm showing here, gravity is what makes the moon go around the earth, and it's what makes the earth go around the sun that I'm showing there. So this girl bouncing on the trampoline and the earth in its orbit around the sun, all acting under the influence of gravity, what Newton initially called gravitas. So this is a pretty universal phenomenon. It's kind of everywhere in our universe. And the laws, that's why we call these universal laws of motion. If we can figure out what's making gravity work, it's going to apply everywhere in our universe. So the man, the myth, the legend, I said I wanted to talk to you about Isaac Newton. So I've introduced the man. Now let's get to the myth. So the myth I can kind of show in a little animation that's going over here on the right. So the myth was that Newton was sitting under an apple tree, in his garden where he was working out his theories, and an apple fell and hit him on the head. And that caused him to think up all the laws of universal gravitation. He was inspired by the falling of the apple from the tree hitting him on the head. And these laws of universal gravitation explains how gravity works. I'm not going to say he discovered gravity. So some people would say, yes, the apple fell and hit him on the head, and he discovered gravity. I don't think he discovered gravity because, like I said, everybody already knew about gravity, right? Everybody knows when you jump up, you come back down. Newton was the person who explained how it all works. Why does it happen? And how does it happen? He didn't discover it. It was just there, but he was the first person to piece it together. So that's a myth that he was sitting under this apple tree and the apple hitting him on the head did it. But is this myth fact or myth? Well, the fact is something like this actually happened. So not so much a myth. Newton himself often told the story that he was inspired to formulate his theory of gravitation by watching the fall of an apple from a tree. This is coming from him himself. In fact, the great French writer Voltaire wrote in, as you see on the screen there, his essay on epic poetry, 1727. Voltaire wrote, Sir Isaac Newton, walking in his gardens, had the first thought of his system of gravitation upon seeing an apple falling from a tree. So Voltaire knew people who knew Newton, and he said, this is a true story as he understood it. Newton himself, so this is coming from the man himself, said in a letter to a friend later that he thought when he saw that apple fall, I don't know if it hit him on the head, but he certainly was sitting under the tree watching apples fall. He thought, why should that apple always descend perpendicularly to the ground? Perpendicularly means the ground is here and the apple falls straight down and hits him there. Why should that apple always descend perpendicularly to the ground? He wondered. Why should it not go sideways or upwards, but constantly to the Earth's center, which is what the ground is? He reached a conclusion. Assuredly, the reason is that the Earth draws it. There must be a drawing power in matter. Now we would say that they're attracting each other. Masses attract each other, but he called it a drawing power. Something about the earth is drawing the apple to it. And that's why, because the earth is underneath it, the apple wants to get down into the earth. It doesn't want to get away from it. It doesn't want to go sideways. They're attracting each other. There's something going on there. That's why it wants to fall. That's a really important conclusion. So the legend, the man, the myth, the legend, that myth, that story, that fable has now moved in, as we are centuries later, moved into the realm of legend. And this idea of the apple tree and Newton drawing inspiration from it. I would argue that this apple tree is the most famous tree in the world. I really do believe that. I've tried hard to think of other trees which are more famous and have existed in our memory through the centuries, and I can't think of any. So this tree is still celebrated around the world, particularly at universities and particularly around physics departments at universities. So here's an apple tree at Trinity College, Cambridge. Here's an apple tree that was installed at Clemson University. These are not going to be the original apple trees that Newton sat under. These will be offshoots were taken of that tree and then planted, and then offshoots of those trees. So they are direct descendants of the exact real tree that Newton used to sit under that helped him think up the theories of gravity. And so when you go to universities and wander around campuses, you can oftentimes see these things that look like apple trees, and you're going to see plaques sitting near them. And you might think, oh, why is there a plaque near a tree? And if you go up to one plaque or a sign, it might say something that looks like this. So here's a plaque that you would see underneath a tree, Sir Isaac Newton's apple. This apple tree is a descendant by vegetative propagation of a tree which grew in the garden of Woolsthorpe Manor near Grantham, and which is reputed to be the tree from which fell the apple that helped Newton to formulate his theory of gravitation. The original tree is said to have died about 1815 to 1820. So if Newton was he published the Principia in 1687, that means that this tree died 130, 140, 150 years later. So that's probably the lifetime of an apple tree. It's a pretty well-lived apple tree. So obviously that tree's not alive anymore, but we would take shoots off it and regrow a new tree. So that's why they call it a vegetative propagation. So very well remembered trees. And it's an honor to have a tree that's a descendant of Newton's original tree if you're a physics department, because it's so important to what we do as physicists. So why is this so important? So now I just want to let you know, why is it that Newton is remembered for this? Because if all Newton had done was explain why apples fall down, okay, that's kind of cool, but that's not so important because the apples falling down don't really affect your daily life at all. But Newton did something much more different. What he did is he realized that the exact same thing, whatever this was that he came to call gravitas, the same thing that made the apple fall down to the center of the earth, that is explaining this drawing power of matter. It's the exact same thing that makes the moon go around the earth, and it makes the earth go around the sun. And all orbits everywhere in the universe depend on this force of gravity. It controlled the motion of the comets, which is why he was talking to Edmund Halley. It controls the motion of the planets. It makes the tides come in and out because gravity is actually pulling on the water on the earth due to the gravitational effect of the moon, and so on. All right, so this actually is explaining what Galileo saw in 1610. So the thing is, if you look up with a good telescope, you can see the moons of Jupiter. So what I'm showing here is, this is a time-lapse photo of a, spanning a little bit of time, showing the planet Jupiter taken from an earthbound telescope. And you can see 1, 2, 3 dots up here. These are the moons of Jupiter. So even today, with a pretty decent telescope, you can actually look up at Jupiter and see the moons of Jupiter around it. Galileo did that in 1610. All right, so I'm kind of showing down here is an animation showing the actual sketches that Galileo made, and then kind of this is a schematic going above of where these planets were. So Galileo had a telescope, he looked up, he could see Jupiter, and he could see these moons going around Jupiter. So as early as 1610, they knew that not just our moon was going around the Earth, but when you looked out into space, you could see other moons going around other planets. Why? Why do they go around these planets? Why are they stuck to the planets? Why do they not fly off into space? Newton was the person who worked out the why. This was a universal phenomena, as I'm saying here, that he called gravitas. It's going on everywhere in the universe, and all inspired by the falling of the apple. So how can I explain this idea of the orbit? So why is it that our moon goes around the Earth due to gravity? And why is it that the moons of Jupiter go around Jupiter due to gravity? How can I explain that? Well, we are going to do a thought experiment. Physicists love to do thought experiments. It's an experiment that you do in your mind. You have to imagine doing it in your mind, all right? Because this experiment that we're going to do called Newton's cannon, you cannot actually build it, but you can think about it. All right. And that, of course, all the power of science goes on inside your mind. So if you think about it, that will be enough, because then you can understand the idea. So we're going to do this thought experiment, which Newton was thinking of, called Newton's cannon. To get a little help with that, I'm just going to show a quick 2-minute clip from the fantastic special series Nova. I give my highest recommendation to all of you to watch as much Nova as you can. Great stuff. If you get a chance to watch Cosmos as well with Neil deGrasse Tyson, just fantastic shows with way better animations and visualizations than I can do. Really, really worthwhile. But this is probably the best explanation of Newton's cannon that I can find. So 2-minute long clip. Let's check that out.
To show how gravity works on Earth and in the skies, Newton designed a thought experiment. He imagined firing a cannon from the top of an extremely tall mountain. From his first law of motion, he knew the cannonball would travel in a straight line at a constant speed forever. But gravity pulls the ball downward. If its speed is low, the cannonball hits the Earth near the mountain. The higher the speed, the farther away the ball lands.
If you throw it faster, it comes farther away. Even faster, farther away. Even faster, it may go 1,000 miles. Even farther, it may actually go almost halfway around the Earth and there hit the Earth.
Newton imagined that if its speed were high enough, the cannonball would travel all the way around the Earth and settle into orbit.
The orbit of the cannonball around the Earth was a balancing act between the cannonball's tendency to fly off in a straight line and its being yanked back towards the center of the Earth continuously by the force of gravity. So in Newton's picture of the world, there were two things. The natural tendency of an object to travel in a straight line, which was true on Earth or in space or anywhere, and there was the attraction of gravity, which was true on the surface of the Earth, and it was true up in space.
Newton's breakthrough was to see that the moon's orbit around the Earth and a cannonball's motion on Earth were governed by the same law of gravity.
There you go, right there. See, that was Newton's genius, and Newton was a genius because he connected these things. He made that connection. The apple falling, yes, is one thing. The moon going around is another thing. Wait a minute, that's the same thing. Nobody had ever really appreciated that before. That was a moment of inspiration and a moment of genius for which we still remember Newton. So I would say we owe a lot to this very, very famous apple tree, which is not just a myth. The apples falling down and this beautiful animation of the rotation of a galaxy, it's all the same thing due to gravity. So how much do we through the centuries owe to this apple tree? And just as importantly, to the man sitting under that apple tree who got hit on the head by an apple. He looked up and he didn't say ow. He wondered, why? Why does that apple fall down? And it all came from that, the inspiration, Newton's famous apple tree. Thanks so much for joining me, everybody. I hope you got something out of this. This is just a fantastic story about physics and history, two things I'm passionate about. Hope you enjoyed learning about this. I can't wait to talk to you again. See you in a little while. Bye.